Hey guys, what's up? See, I'm back here and I'm back with, another topic from aldehyde, ketones and carboxylic. Probably most of you know, and in case you do not, then I have to repeat a little bit of that. I'm doing carboxylic acid and right now, I'm on a topic called chemical properties of carboxylic acid where I've described so many reactions and along with their mechanism. But this time, I'm talking about the reduction of carboxylic acid. So let me go with the topic, but before coming to the writing part, let me tell you what reduction of carboxylic acid here. If you remember in the previous section, at two different occasions I've explained that oxidation of alcohol result formation of carboxylic acid, right? So if you use a strong oxidizing agent, you convert the alcohol into carboxylic acid, right? A primary alcohol. You have to remember a primary alcohol converts into carboxylic acid, right? In case you are interested to know what happened to the secondary, they converts into ketone. But that's something, I shouldn't be taking right now. So right now, I'm actually talking about the, reversal of the whole thing. What that mean? From alcohol we are producing carboxylic acid. Then if you let the carboxylic acid undergo reduction, you will be able to produce alcohol back. So that is what the topic is. So let me take you through the reaction. But before that, I have to introduce with that one as well. So I'm talking about alcohol, right? So when an alcohol is oxidized, in presence of strong oxidizing agent. So what is strong oxidizing agent is? This must be like KMnO4, this must be like K2Cr2O7, or if you remember, this may be also John's reagent. What this John's reagent was, let me write. This John's reagent was, H2SO4 plus chromic oxide. So this is what called Jones reagent, and this is a strong oxidizing agent, just like you remember the KMnO4 and K2Cr2O7. So if you react the primary alcohol, this is your 1 degree alcohol. This is 1 degree alcohol. So if you react 1 degree alcohol in presence of this one, this directly converts into carboxylic acid. So this is something we have already done. Now what I'm going to explain you right now, I'm explaining how you can get back this alcohol, right? So this is what your topic is. This is what our topic is. We are, trying to get to know how carboxylic acid can be converted back to alcohol, right? So let's start that and see how the process is going to be. So first I'll take you through a reaction and then I will come to the mechanism part. So let's take, the carboxylic acid here, and with the carboxylic acid, what you need, a reducing agent like lithium aluminium hydride, right? Or maybe, even a diborane can be used, B2H6. So a diborane can be used, and you also may need heating as well. So if you react the carboxylic acid with these two reducing agents, this will convert into alcohol. So this will convert into alcohol. So this is what happened, right? So this is actually the reversal of the oxidation. And what reversal of oxidation is? Reduction. So if you oxidize alcohol, it converts into carboxylic acid, but if you reduce carboxylic acid, you will get back your alcohol. But the reagents are different here. There the oxidizing agent was KMnO4, K2Cr2O7, or even John's reagent. Now you have lithium aluminum hydride or B2H6 or any other reducing agent, right? So now we need to go back and check out how this reaction actually takes place. So we have this topic and it's called mechanism. Let me write a little bit. Mechanism. So what this is, we are going to convert the carboxylic acid back into alcohol. So let's take a carboxylic acid here. Suppose I am taking this one, right? And in case you want to take specific one, you can take specific one here. Suppose you are taking this, ethanoic acid. right? So we are going back to the alcohol actually. Let's see how this happened. So like I said, this reaction is taking place in presence of lithium aluminum hydride. So if you remember, this is a metallic hydride. In a metallic hydride, hydrogen exhibit -1 as an oxidation state. So what that means, this reagent is a source of -H or H negative, I would say. So this will produce a hydrogen, ion as a negative one. So you probably understand that, because I have repeated this more than 50 times, that this carbon is electrophilic. This carbon is electrophilic and this oxygen is nucleophilic. So this is in search of electron. So this will approach to the carbon, but in order to have a bond, this has to shift its electron right over the oxygen. So in that case, this will convert into a single bond and hydrogen will attach itself to the carbon. So what you get here, you get this product here. You get carbon, single bond, oxygen with the negative charge, and then you get a hydrogen ion right here. Now it's a hydrogen, and along with that you have OH. So this is what happened in the first step. In the next step, what happened? This happens to be a protonation. Let me write this. In the next step, protonation takes place. So what protonation means? Protonation means adding the hydrogen ion, right? Why it needs hydrogen ion? Because this oxygen is strong nucleophilic and it needs it needs to stabilize itself. So it's looking for a hydrogen ion like this. So this will be moving right here. This will be moving right here, and in that case you will get a product which is going to be something like this. So this is what the product looks like. So you got 2 OH on the same carbon. So now the question is it stable? Then I must write here. This is quite unstable here. This is quite unstable. Let me tell you the reason also. Quite unstable. If you remember, 2-hydroxy group on the same carbon, this result a strong hindrance, strong steric hindrance, and that's why it's not stable. So because it's not stable, so immediately it has to have some sort of releasing group coming out, and this will release that. So what you see a releasing group right from here. So this will be coming out here. This will be coming out. Right? So what exactly happening? This is involving elimination of the water, and for doing so, what will happen? This bond will undergo cleavage. You have to understand that hydrogen will come out as a positive and this will come out as a negative. So they will form a water, and along with that this will converts into C single bond O, right? And along with that, O has a negative charge, and right here you have a hydrogen. So water has has been released here. Now what happened here? What happened here? After this bond has broken, the carbon develops a positive charge while the oxygen develops a negative charge. Now in that case, this will result a back bonding. And due to the back bonding, this will converts into an aldehyde. So let me write this here. This will result formation of a aldehyde. So this is what the product is coming out. So ethanoic acid has converted into ethanol. So you have got your ethanol, but we are going to produce ethanol. Right? And for doing so, again, what will happen here? This electrophilic carbon and this nucleophilic oxygen will approach another H negative. So where this H negative is coming? Again from the lithium aluminum hydride or any reducing agent you are using. So this will approach now to the oxygen. As a result, this bond will undergo cleavage, and it result formation of next step. And what that next step is? This one is your next step. So carbon has now a single bond, oxygen with a negative charge, right? And there you have a hydrogen, and again you have a hydrogen right here. Finally, what will happen? This will undergo protonation again, right? Let me write this. This is another step where protonation takes place. Protonation. And due to protonation, this hydrogen will approach the oxygen and it will result formation of your ethanol finally. So you get your CH3, right? You get your C, another C, you have an OH here, right? And you have H and you also have an H. So what this is your ethanol. And this is what we were trying to convert. So actually this is a very, very interesting topic appears to be. Not for me because I've been doing this for several times, but for you it's going to be very interesting. So reduction of carboxylic acid is what I just made you go through. This is a complete mechanism where each and everything have been described. What happened? Continuous protonation and deprotonation of carboxylic acid, and that result formation of the ethanol or alcohol. So whatever carboxylic acid you are taking, you will get the respective alcohol. So I hope I have made you go through the reaction. You have understand everything. Just take a screenshot if you need, and in case you need to watch it again, go back and watch it, right? I would say I have to wind this right here, and in the next topic I will talk about the decarboxylation of carboxylic acid. That's also going to be very important. We are very, very close to completing the chapter, but remember, I'm not just completing, I'm taking each and every topic from your book. So you just pay attention. So thanks for watching. Take care and have a good